one of the world's most extreme rides.
You're building a big toy.
Some toy. It's the jigsaw puzzle from hell.
That's the difficult part.
More than 200 tons of steel. Only 4 like it on the entire planet. And the hardest work can only be done by hand.
How the hell are we going to fix that?
The parts will be made not in one mega factory, but 2. In 2 countries, half a world away from each other. Strap in. It's going to be a bumpy ride. "360 meters of pure adrenaline. Gut-wrenching heights. Heart-dropping depths. G-forces pushed to the max. And if that's not enough, you get to do it all. Twice.
That looks to me the most scariest of every product which we built. We are special in this field because we do everything from concepts, early designs, R&D, till the end of servicing. We are quite unique.
Enter the iconic Vekoma Rides mega factory in Vlodrop, the Netherlands. To discover what it takes to create terror itself. In the shape of the giant inverted boomerang. From its soaring towers to the innovative way to reach them. From its groundbreaking cars to its head-spinning track. This isn't a ride for the faint of heart or weak of stomach. And no one knows that better than the man who created it.
You're building a big toy.
As one of the company's top design engineers,
Upside down.
Stefan Holtman makes a living scaring the daylights out of people.
You feel yourself like you're in a jet fighter. Because they create a sensation what you cannot get somewhere else. There isn't a simulator in the world or a game or whatever to give you the experience what you get in a roller coaster.
In the entire world, only 4 of these rides exist. The 5th is about to be built in Shanghai, China, at the Jingjiang Action Park, where the construction challenges are as stomach-flipping as the ride. For starters, the designers have to squeeze their new coaster into a tiny plot in the middle of this busy park. Shanghai's location poses the second challenge. Designers have to worry about everything from typhoons to earthquakes. Safety poses the third challenge. Designing a ride that scares you, but won't hurt you. Distance poses the fourth challenge. Building the coaster in the Netherlands and shipping it to China is not an option. The tracks alone take 260 tons of steel, broken into 37 enormous segments, too expensive to ship. So the Dutch designers have to bridge a cultural chasm with the Chinese engineers who built the track. here in Xiamen. 1,000 miles from Shanghai, but a stone's throw compared to the Netherlands. This is Vekoma Rides, China, one of the country's premier roller coaster factories. These qualified steel constructors are experts at roller coaster production. But every individual ride brings its own unique challenges. Under the tutelage of the Dutch team, they'll perform superhuman feats with steel, as you'll soon see. In all, these engineers must build more than 300 meters of track. Just organising the logistics is a headache. Planning the production, estimating the workforce, lining up equipment, and ensuring all the parts come together at exactly the right time.
The most difficult part to build on a roller coaster stays the track.
Every single part has to fit together perfectly. And this track compounds the challenge. The giant inverted boomerang is the second generation of another Vekoma Rides coaster, the original boomerang. The company has built more than 40 boomerangs around the world.
And it's the most successful ride in history of roller coaster building.
But one customer wanted to add a twist.
When he said to me something like, I want a new ride on the footprint of a boomerang, which needs to be more spectacular, you have to come up with something.
Stefan came up with more than just something.
I have already a lot of rides which are sitting on the track. Can't you do something which is inverted? Looking at this piece of equipment, the tower, I thought, okay, it's vertical, it doesn't need much space, and maybe we can come up with something for this one here. Of course, it's always limited to safety regulations, which is #1 priority, and that often kills the idea.
For designers, the whole game is to push the edge of terror without stretching the envelope of safety.
So you have to be creative to overcome that and make sure it's still something spectacular.
It is. The ride he came up with, the giant inverted boomerang, is one of the world's most thrilling roller coasters. Only 4 exist on the entire planet. Shanghai will make 5. From the top of Tower 1, you plunge 60 meters. Race through the Cobra Roll. Loop the loop. Climb Tower 2 and brave the monster a second time, backwards. The thrills are magnified by going from near stall to autobahn speed in mere seconds.
The giant inverted boomerang is 26.2 meters per second, which is 100 kilometers per hour. This whole ride, you travel 600 meters of track. You go 3 times forward upside down, 3 times backward upside down. So a total of 6 times, which given the shortage of track is the most intense ride there is at the moment.
Producing this high adrenaline experience in the tightest space possible forced Stefan to use an ingenious twist. The Cobra Roll.
Which is a half a loop, followed by a helix part, and going into half a loop again.
Looks simple enough, until you turn it all upside down.
Yeah, that's how it turned out to be the giant inverted boomerang.
Instead of riding atop the rails, the train travels beneath them, turning the entire experience on its head.
Yeah, that created a lot of mind thoughts within our engineers. To see, okay, how the hell are we going to fix that?
back in Xiamen. This baffling design will also test the workers who have to build it. Forging this coaster takes 720 tons of raw steel. And that's just for the track and columns. The total weight of this monster reaches 875 tons. Next comes a job for Superman. Bending the steel that forms the track.
Every roller coaster has different angles, curves, radiuses you have to build. Every curve consists of transitions to the next curve.
This machine starts the process of bending. Lengths of steel pipe are laid straight between rollers, and then the machine takes over, slowly molding the steel into shape. The process is constantly monitored for accuracy. Tracks are composed of 4 key components. The pipes, the rails the cars ride on, the backbone, which supports the track in mid-air, the ties, which hold the rails together, and the saddles, which connect the track to columns. When all the parts come together, this is what a single section of track looks like. And for the giant inverted boomerang, the workers have to make 37 sections. While the track takes shape in China, seats are constructed here in the Netherlands, home to the rigs, labs and expertise of Vekoma Rides. First comes the design. After completing a computerized version, they build a mock-up, like this foam model for the company's latest seat. From the mock-up, they'll build a mold for casting a prototype of the seat. Then comes a vital step: testing the seat to ensure it's safe to ride in. Meanwhile, back at the Chinese mega factory, the pipe emerges from the bending machine. But a machine can take kinkiness only so far.
它这个过山车本来它都是扭的嘛，它这样转来转去的这样，它在这个上面弯这个2位，它但是它不会扭嘛。
So this stage demands the human touch. To bend steel without the power of machines, workers exploit simple physics. Heat expands metal.
The shape of the track and the design and the bending of the pipe, that's where the craftsmanship comes to work. And yeah, that's something you need lots of years of experience to make a smooth transitions and a smooth bending of the pipes to get a very good feeling of the ride.
Actually, all the fitters here, when they come to here, they never touch the track fabrication. They get trained by the Vekoma supervisor. All the people will take around 4 years' time to make them trained and know how to work on this kind of tools.
After heating and bending the pipe, they tap a second principle. Cold contracts metal.
Water only makes it faster because it also can cool by air. But it maybe take 2 or 3 days, maybe. But use water are only 2 or 3 hours.
Throughout the entire stage of construction, workers will constantly check and recheck their work. Because this is no place to find a mistake.
This bit feels good.
Like all seats designed by Vekoma Rides, the prototype seats for the giant inverted boomerang go through rigorous testing. Here in the Netherlands, they need to verify the clearance envelope.
A CAD model doesn't tell us everything. So we will ask passengers to sit down and then, for instance, reach as far as possible. And then we can take dimensions and check with our theoretical model, is this length in compliance with what we have drawn in our computer.
It sounds routine, but it's actually vital. When you ride a coaster, you speed past the structure of the ride itself. Designers call the clearance envelope, which is the proximity between riders and the coaster structure, the balloon.
We design actually a balloon all around the people, so where in that balloon people are allowed to extend their hands, stretch their arms, and they should not touch anything within that balloon.
It's a constant cycle of testing and modification, and every inch of the ride is covered.
There is a brake fin in the track, and you can see that this passenger is tall enough and he can touch the brake fin, which is not allowed because then he could really hurt himself. In that case, we have to redesign this piece which is into the track to lower it so that there is sufficient clearance that we will not end up in this situation.
But a good designer keeps the clearance envelope as tight as possible to make the ride as scary as possible.
If you're designing very close to your clearance envelope, your mind always says, because you're in a distance and you're traveling at high speed, you always think that you're not going to fit.
And that heightens the fun.
Those effects create an extra dimension in the ride, which gives you a more sensation of speed and thrill.
When you're flying down these rails at 100 kilometers an hour, you don't want to collide with a mistake. So it isn't just the seats that go through extensive testing. The track also demands precision. To ensure they've achieved the exact curvature demanded, the Chinese team moves the pipe to a jig for verification, using nothing but old-fashioned plumb bobs and chalk outlines. Before the jig is erected, the team creates a precise outline along the floor. It's a skillful mix of mathematics and experience. When these guys finish, this engineering graffiti will exactly mirror the position and dimensions for this segment of track. The jig that holds the track is then constructed according to this outline. Plumb bobs are lined up along the length of the rail, and each must line up perfectly with the markings. If any plumb bob is off the mark, more bending.
Very difficult job, especially for how to heat and how much need to heat and where to heat.
It takes a vast amount of patience, but when the pipes finally reach their proper shape, workers begin welding ties. These ties hold the rails together. After all the ties are welded, comes another accuracy test, verifying the banking. Curves in roller coasters need banking for the same reason roads do: comfort and safety.
If I would go through a curve with 100 kilometers per hour and make it flat, I would shift to the side, like with a car. It's not pleasant for me, or for all human beings, to be shifted to one side into your restraint sideways. And then you would break your bones.
Workers verify the banking using a tool designed specially by Vekoma, called, of course, the banking car.
We can use the banking car. Going through the tracks, we get series of figures. These figures we put in Excel, then it shows goes smooth or not. Our roller coaster goes very smooth. It's not like boom, boom.
With banking signed off, the next job is attaching the saddles, the structure that will connect the track to the column. Then, a last crucial inspection. A poor weld can leave microscopic cracks, invisible to the naked eye. But they have an ingeniously simple way to spot problems.
我们做切线的时候，做我们表面脂粉检测的时候，它要先喷一层薄薄的均匀的反差剂，然后呢，再用我们的磁悬液，这我们叫黑色的这个磁悬液，它里面有颗粒很小的一个磁粉，铁磁粉。然后我们做的时候就是对着这个焊缝做，有切线的话，它有显示出来，用我们眼睛来看。OK， 很好，这里面没有切线 ，no problem。
Each section of track is about 10 meters long, and that's no accident. 10 meters is the length of a cargo container, because each section will arrive at the amusement park, prefabricated for rapid installation. When the last stretch of track is finally complete and approved, it's off to Shanghai. Here at Jinjiang Action Park, a whole new workforce moves in to assemble the huge jigsaw. Coasters take 1,000 different paths, but every design starts from the same point: altitude. Because height creates speed.
It's just normal physics. If you drop something from height, the higher you drop it, the more speed it gets. And principally, if I drop something from 60 meters high, it will return to a height of 55 meters, depending on the amount of friction I have from the wheels and from the air, what reduces the speed of the train. And with that energy, I can go to the next bump and to the next one. So I can then make a whole series of elements until the energy is done.
Maintaining this energy is the reason you never see a loop at the end of a ride.
Because there isn't enough energy to put it in, because you need certain height for that. So the high elements are always in the beginning after the lift, and the more you go towards the end of the ride, the more elements you see, like a corkscrew, which is built very low, or a horizontal curve. And that in your mind also determines the layout of a ride.
So for a designer, it's all uphill from downhill.
It's very easy to come up with a station layout and a lift. It's also easy to make the first drop, the first elements, but then to make it exciting all the way to the end, that's the difficult part.
Not every hurdle on this project involves nuts, bolts and steel.
For us as project managers, it was difficult in communication with the customer. We had to use our Chinese colleagues to do a lot of translation in between the parties. So that was definitely one of the challenges we face in this project, that the language issue is quite important.
With the towers up, crews can move on to the body of the ride, columns and track.
So every piece is numbered, gets labeled, and it's in principle a big jigsaw puzzle.
You look at the drawing, so that piece is for there, that piece is for there. Build everything together on the floor, then the big crane will lift it up and just put it on the foundation.
The structure looks sturdy, but how do they know it'll hold up once the monster ride is unleashed? Someone has to guarantee the entire coaster can handle the forces built into Stefan's design. Someone is Tony Schoenville.
So every single column, every piece of track, we need to ensure that it will be strong enough.
Foremost, he had to ensure the structure can withstand the weight of the train. Fully loaded, it weighs more than 13 tons. But the force of acceleration ramps up the effective weight to 60 tons. They have to factor in the weather too. Wind, heat, and cold. That's why every roller coaster is different. Another part of Tony's job was calculating the vital components that hold everything up. The columns.
Of course, they are manufactured at some place other than the building site, so there are limitations in how big you can make the column sections because they need to be transported in a truck or in a ship or whatever.
After weeks of sweat, the giant inverted boomerang towers over the park. But weeks of careful and precise work still loom, installing everything that makes the coaster go. The car itself isn't powered by electricity or batteries, just gravity. And this is the component that harnesses gravity, the catch wagon. It's not only fresh off the boat from the Netherlands, it was designed and engineered by Vekoma Rides. Its genius lies in its ability to power the ride without interfering with the ride. Here's how it works. On the platform, the catch wagon grabs a fin on the front of the train and hauls all 12 tons of it up to the top of Tower 1. Then, release. Momentum and gravity carry the train through the ride. On to Tower 2. Here, the second catch wagon grabs the train in mid-run without slowing it down and hauls it up to repeat the ride in reverse. On the return to Tower 1, the first catch wagon grabs the train and lowers it to the station. It's as simple as it is efficient. But efficiency creates a hurdle. Because of the design of the giant inverted boomerang, the train actually passes through the tower to reach the top. The result? A structural hole in the tower.
So if I make a gap in the tower here, I have to remove all this structure and make the tower extra stiff on the sides. You need to put a lot of more steel into this tower to make this stable again. So those challenges passing through the tower, there were the extra difficulties for this ride to build.
The catch wagon is the only part of the entire ride that requires power, because gravity does the rest. Supplying power to the winch motors is this electrical cabinet. In effect, the heartbeat of the entire coaster. For extra protection, the cabinet also contains a backup system. Because the nightmare haunting any theme park is power failure, leaving riders stuck in mid-air.
Dit is een generator, een noodgenerator. Als de spanning weg zou vallen, kunnen we met de noodgenerator de noodwinch bedienen. Dan kunnen we nog altijd de trein en de mensen eruit halen als ze blijven steken op de lift.
Don't be scared, it's the most safe form of transportation in the world.
At the start of the ride, you're dangling almost 60 meters high. But never fear.
This is the rail where the train attached. The wheels are on each side of the track to prevent the train from falling down if you're upside down or whatever. So it's always secured on the track on both sides. In the very early days of roller coasters, you had only few running wheels and you had some steel parts going along a track to prevent it from falling off. But of course, when you get airtime on a roller coaster or side movements, that grinds a lot through the track. So during the years, the guide wheels and upstart wheels came to it.
But what if those wheels do fall off?
Well, if they take the wheels off, there's always this beam and those two steel beams to keep it steady on the rails.
The catch wagon that hauls the train up the tower has its own safeguard, called the anti-rollback.
There was the crest of the lift, so that's the highest point. In this chain guide, the chain is running and it hooks with a chain dog. It pulls the train up towards the top of the lift. So that's the normal clack, clack, clack sound you hear when you're going up the lift. On the new systems, we made it silent so you don't hear the noise anymore. So if the chain breaks, this system will always grab the train, prevent it from falling down.
And you're also safeguarded in what seems the most precarious position. Upside down. In the improbable event that a car ever stopped while upside down, the wheels would keep the car secured to the track, and the shoulder harness keeps you secured to the car. And even the harness has a safety backup.
You're as safe as you possibly can be.
Besides built-in safety, designers have the laws of physics on their side. Even at the top of the loop, you're going so fast, acceleration pushes you into your seat. The pressure of that acceleration is called G-force.
That sticks you through the track in your seat at all time.
You feel G-forces every time you barrel down a runway or take a plunge.
It's like you take the elevator, you will suddenly feel you lost or you get very heavy heart.
The size of the park itself ensured high G-forces because the tight footprint means tight turns.
So the more compact I make it, the more tighter the curves and everything will be, so the more stress you will get on the human body. And you have to find a balance between what's acceptable and what's not.
The giant inverted boomerang raises the G-force bar.
But if you would have a design with pure loops, you could have a bucket of water on your lap and still have it on your lap in the station because the forces will stick the water into the bucket.
Roller coasters is all about G-forces. You need fast parts, you need slow parts. If you got a good combination of that, then you got a good roller coaster.
It's all about getting the G-forces and the stresses on the ride in such a level that it's enjoyable for people.
For engineers, it's simple mathematics. From the height of the track, the angles of the curves, and the speed of the train, they can calculate the G-forces on the riders.
The biggest problem is always the limitations you have to work in within the boundaries of the G-forces and the acceptance, what humans can take.
And the limit is 5 Gs, equivalent to 5 times your own body weight.
Oh my God!
You can go to a limit of 5 G, but that's only accepted for a few tenths of a second. The 5 G on the upper end has to do with the blood restraint from the heart to the brains. If you go down more than 3 G, your blood stops flowing to the brain, and if you keep that for more than 2 seconds, then you have the possibility to go in unconsciousness.
Forces also limit who can ride. Above 5 Gs, children can suffer muscle damage because their bodies are still growing. Hence those familiar signs at amusement parks. You must be this tall to ride this ride.
Most of the time it's driven by the G-forces and not by escaping from the seat.
And that's the equation of roller coasters. Every shot of adrenaline requires an ounce of precision.
Okay, it is easy to make the ride running, but the most hard part is to get it really safe for people.
Before we start running trains with people, we want to know every safety aspect has been taken care of first. So nobody is traveling with a train until that is done.
Silvio van Doren is testing a crucial system. The software that keeps the giant inverted boomerang safe. For Silvio, the testing is personal. He designed the software.
So we're going to think on what can go wrong. The platform can go up, a gate can go open, a brake can go close when it is not supposed to.
This control panel monitors every safety sensor for the entire ride. To be twice as safe, every sensor has a backup. If any part of the ride malfunctions, a sensor lights up and the ride shuts down.
If the train is leaving out of the station, the platform has to go down. It has to be detected that it is down, and it has to be locked, that no one can hit the platform.
Silvio also has to ensure the train doesn't leave unless all riders are safely restrained.
You can see that now this seat is open because we don't have a green light. We're going to check the train, and you see that it is into seat 3.
In this case, a sensor on the back of the seat relays the message to the control panel.
So when we put the restraint down, both sensors will be okay, and then we can check on the operator panel if the ride control detects that the restraints are closed and locked.
Besides riders being secured, gates must be closed, especially after the train has left the station.
If one of the entrance gates has a fault that it is not locked, the train will stop on top of the lift, and then a maintenance guy has to come and then reset the whole system before the train can come down.
Because lives are riding on these rails, every stage of work is verified for safety. Shanghai's climate is a recipe for corrosion. Summers are hot and wet. Year-round, it rains about 1 day out of 3. Metal and water don't mix. The coaster builders don't retool for each climate they work in. Instead, the company gets the jump on Mother Nature.
Right from the beginning, we pick the worst case environment and make sure that everything is equipped for that need.
Like stainless steel, to resist corrosion as well as fatigue.
When we started in this business, the theme park was just open for 3 months, and now we see that the theme parks are open for the whole year. And so we really need to design for fatigue.
The coaster builders take whatever nature can throw at their equipment and throw it first, as they're doing with this gate.
We pollute that with sand and other materials to see in practice how long it will take before a customer needs to exchange, for instance, the guiding plate.
An amusement ride is like a cinema. If the projector shuts down, everything shuts down. So a theme park can't afford constant breakdowns. So if a gate must open 100,000 times between scheduled maintenance, they'll test it up to 100,000 times. With the grand opening just weeks away, still more safety checks remain. Among the final tests, measuring the acceleration of the ride to ensure it doesn't outrun the limits of safety. At top speed, the train will hit 100 kilometers an hour. For this test, it's too risky to use live subjects. This plastic volunteer is filled with 80 kilos of water, the weight of the average passenger. If the dummies pass this test, the ride will face its final exam. With human volunteers. On a ride where the view is paramount, designers also had to answer a seemingly simple question: how to arrange the seats. Some roller coaster cars seat 4 abreast, and pity those stuck in the middle. It's like being the middle kid on your parents' back seat.
They cannot see sideways because there is a lot of seats around them, so that they cannot really overview the park.
For the giant inverted boomerang, designers hit on a simple but clever solution: staggering the outer seats an unobstructed view. In all, the boomerang will have 8 cars, for a total of 32 passengers per ride. Adding more cars would increase the weight of the train and make it impossible to loop the loop. Now the seats are about to be filled. After months of labour, the combined skills of 2 mega factories, and the sweat of the construction team, Shanghai's latest mega coaster is ready for its human guinea pigs. And who better to test it out than the guys who built it? This is the moment of truth.
You're a little bit nervous before you make your first ride.
Of course, it's been calculated dozens of times. We have done multiple checks. But still, for the first ride, everybody is nervous to ride it.
Okay, ready?
Once Silvio presses the button, there's no turning back. Where you sit influences your joy or your fear. Think of it as a mechanical version of Crack the Whip.
If you like to enjoy the higher G-forces, then you should go to the front or to the back.
On the return to Tower 1, the catch wagon grabs the train in mid-flight. Back to the station, safe and sound.
OK 了 ，OK 了。
And the verdict?
当你从上面往下看的时候，有一种跌落的感觉。当从塔一瞬间释放的时候，达到4个 G 的速度的时候，心脏那种负荷让你非常非常的紧张。当冲到站台的时候，100多公里每小时的速度，你感觉到非常非常酷，非常非常爽。然后运行到翻滚环、运行到循环的时候，那简直是一种享受。当你达到塔2的时候，有一种一飞冲天的感觉。不知不觉的时候，顺着塔架滑下来的时候，让你没有一种感觉到就是已经滑下来了，一种自由落体的感觉，非常非常舒服。
When Shanghai's giant inverted boomerang opens, it'll be a ride to flip over. A dizzying machine built by steady hands, with eyeball accuracy and fingertip precision.
I always try to come up with something which is still fun, which is not going over the limit, because you want people to ride it over and over again. It's no use for a roller coaster designer to make a ride where people go in once and then after that, okay, done that, and too much for me.